given this function, we want to determine the value of k that will make this function continuous over its domain. So this is a piecewise function. We have the square root of k times x for values of x that are between 0 and 3. And then the second piece is the function x plus 1 for values of x that are between 3 and 10. Okay, so the idea is, depending on this value of k, right, we want to make this function continuous. Now let's take a look, right? Well, the bottom piece, we actually know what it looks like. Okay, so let's draw that. Let's just put a little hash mark, so we do need to be sort of exact here. Not really. Okay, but it's the line x plus 1. Okay, so what does that mean? Right, it means that it's just the y-intercept is 1 and the slope is 1. So we're just going to be a line, right? But we're only using this for values of x that are between 3 and 10. So when x is equal to 3, y is 4. Okay? When x is equal to 10, y is 11. So we're going to sort of be up here, right? So I'm just going to draw this line that looks like this. Now what about for values of x that are between 0 and 3, right? Well, it's the square root of kx. Well, the square root function we know, right? We know the square root function looks a little something like this, right? This is just the square root of x. So essentially what we want to have happen is we need this function to look like this, right? That way this function is continuous. There are no holes in it, right? The limit exists and the function value is the same. Okay? So what do you think that means? It means that for this function, right, when x is equal to 3, right, think about this carefully. When x is equal to 3, what do we need the y value to be? The y value must equal 4. So let's plug that in, right? So radical 3k, we need that to equal 4. Okay, and whatever k is will allow this graph to start at 0, but then right when x is equal to 3, the y value will equal 4. Okay, so square both sides here, right? We'll square both sides. 3k is equal to 16. Divide everything by 3. K is 16 over 3. Okay, let's check this out, right? So, okay, it's radical 16 over 3 times x. Notice what happens when x is equal to 3. When x is equal to 3, those cancel out. Radical 16 is 4, and there we go. Right? So this satisfies the conditions, right? Graphically, there are no holes, there are no jumps, okay, there are no vertical asymptotes here. Okay? And when we look at it more on the definition, right? At this point, right, the right limit exists, the left limit exists, and the function value exists at that same point.